Hi, today we're going to do volume of prisms and cylinders. Remember, if I go too fast, feel free to pause the video. Make sure you have drawn all of the solids down because that will be helpful. Before we dive into volume, I want to talk about the difference between surface area and volume. Surface area, I like to think of it as the area on the outside of the shape. So that is every side of the shape that is exposed to the air. So that's how I think of it. So we're going to, for surface area, you find the areas of all sides exposed to the air. That's why we call it surface area, because it's the surfaces that I can physically touch in real life if it was a solid shape. Volume is a little different. With volume, we're talking about the space that the shape takes up. So we're talking about the inside of the shape. Okay, so surface area is the outside, whatever is exposed to the air. Volume is the inside of the shape. So now that we've covered that, let's talk about the volume of a prism. Okay. Before I give you the formula, I want you to understand where the formula comes from. So what I want to point out is we're focusing, since it's volume, we're focusing on the inside of the shape. So if we take a look at the base, I want you to think of this as the area of the base, the whole base. If I take a look at that, and if I'm focusing on the inside of the prism, if I move this up through the inside of the prism, I'm hitting every single space that is happening inside this prism, all the way up to the top. Okay, so the area of the base, moving all the way up, gives me the complete inside of this prism. Okay, so area of the base, all the way up, gives me every space inside that prism. So area of the base all the way up is the height. Remember, we use capital B for area of base. Now again, with prisms, what formula you use for the area of the base is going to be determined by the shape of the base. So in this case, it's a rectangular prism, so I'm probably going to use just base times height. But if I had something like a polygon base, I would have to use 1/2 times perimeter times apothem. So this is going to be determined by what my shape is for the base. All right, so but in general, the volume formula for a prism is the area of the base times the height. I have to multiply the height so I can go all the way up and get every space inside. One more thing I want to point out with volume, one of the differences, is with surface area or any type of area, we always put units squared on our answer because we're usually taking one dimension, 1 inches times another inches, and together that's, inches squared or units squared. But for volume, we're doing something a little different. The area of a base, since it's area, that's going to give me units squared. And then I have my height, which is just going to be like, 4 inches or 4 units. So that's just a U. Okay, when I go to multiply these two together, we need to remember our exponent rule. So if I have the same base and I multiply, I actually add the exponent. So I'm adding 1 because there isn't an exponent, so it's always 1. So 2 plus 1 becomes units cubed. Okay, so our answers are going to have units cubed on it. Okay, so when we do volume, make sure you put units cubed, and that is why. Next, I want to move on to the formula for the cylinder. Okay, so I have a cylinder. Same thing, we're doing volume, so we're focusing on the inside. So it's actually very similar to a prism. We're going to take a look at the base. The base is a circle, and for a cylinder, the base is always a circle. If I take a look at that base and I move it up through the shape, again, I'm hitting every single space inside the solid and going all the way to the top. So if I take the area of the base and I move all the way up, that gives me all the space inside this shape. Okay, and then when I move up, I'm talking about the height. Okay, so area of the base times the height again. Okay, so it actually kind of follows the formula of a prism. The difference here is in a prism, the base can be any shape, but in a cylinder, the base is always a circle. Okay, so the area of a circle, the formula is pi r squared. So instead of using b in our formula for the volume of a cylinder, we always just put pi r squared because it will never change. And then you're still multiplying by the height. So this is the formula for the volume of a cylinder. So now we're going to take our formulas and we're going to use them in some example problems. So I have 3 of them. The first one is a prism, and we're going to find the volume of this prism. Okay, my volume formula for a prism is the area of the base times the height. Okay, so I take a look at my base. This is my base. Okay, I always use the bottom face because I think of it kind of like sitting on a counter. All these solids that I use, I think about sitting on like a counter, and that would be the base of that solid. So like if I had a box sitting on the counter, the bottom of the box would be my base. So I always use the bottom. You don't have to. If you really, really wanted to, you could use this, but your height is going to be different now that you're using that. Okay, so just keep that in mind. In some of the homework, some of you have made that mistake. All right, so my base is that. And to find the base, since it's a rectangle, the area of the base is going to be equal to base times height. Okay, so this is my base, and this is going to be my height because we're just focusing on the base alone. We're not focusing on the solid. Remember, this height is the height of the 3D shape, the 3D solid. And this height is the height of only the base. I know it gets confusing, but just remember what part you're doing, and that'll help. Okay, since I'm focusing on the area of the base, that H is just for the base. The problem is I don't have that dimension. I know it's equal to these, but none of them are labeled. So I need to find that. So what I want to point out to you is I do give you this diagonal. Now this diagonal is on the face, the front face of this prism. And I know that because this start of the line and this end of the line are on the same side of the right and left of the solid. Okay, so what actually gets created here is you get a right triangle. Okay, I know it's a right triangle because I have a rectangular prism, which means all the corners are 90 degrees. These two sides are equal, so I know this is 12, and I want to find this side here, which is h. Okay, so I'm going to have to use Pythagorean theorem because I have a right triangle and I have 2 sides. So I'm going to do h squared plus 12 squared equals 13 squared. Okay, when I solve that, h is going to equal 5. So right there, that equals 5, and this also equals 5. Okay, so when I do this, I'm going to take my base, 12, times the height of my base only, which is 5, and I get 60. Okay, so right here, the area of the base is 60. Then I need to multiply by the height of the 3D solid only. Okay, so the height of the 3D solid, if this is my base, then my height goes up from there. Okay, so I need, this distance here, which I had already found, which is 5. In this problem, because the 2 ends of the box or the prism is a square, it just happens that these 2 heights are the same, but it doesn't always happen, so please pay attention. All right, so I multiply by 5, and when I multiply 60 by 5, I get 300, and because I did volume, I need to cube the units. They didn't give me units, so I'm going to use u cubed. And there's my answer. All right, we're going to do a cylinder problem next. So So we're going to find the volume of this cylinder. Sorry, that Smart Files sometimes doesn't like my stylus. All right, so my volume formula for a cylinder is pi r squared times height. Okay, so for me, I need to find, again, this is the height of the 3D solid. Okay, so I need that height and I need the radius. Well, I have the height right here, 15 goes from here to here. So that's my h. Okay, and I need my radius. I do not have a diameter or a radius. But what I do have is I have this line goes from here to here. Okay, when you see a problem like this, I want you to think about a can, like a can of vegetables or tomato sauce or something. Okay, when you have a can, if I were to slice it on a diagonal like that, it's going through the inside of the cylinder. It's not on the face. So some of you, when I gave you this problem or similar problem, you guys did this and you drew this in. That's not correct because this is like the surface face all the way around the can, like the label. So think of like the label. The diagonal isn't on the label, it's inside the can. So that doesn't work. Okay. Think of it going through the can, not on the label. Okay, so I'm going through the can and I'm cutting through the center of the base. Well, this through the center of the base is actually the diameter. So if I find that, I can find the radius. You know, the only thing I need to do is identify what kind of triangle this is, and hopefully I can use some of my strategies that I have with triangles to find the diameter. And now again, I want you to think of a can sitting on a counter. Okay, if I'm sitting on a counter, I'm like sitting on a counter like this. The can and the counter is 90 degrees. Okay, so if that's 90 degrees, this has to be 90 degrees. Because, you know, linear pair, they have to add to 180. Okay, so what I just determined there was that this triangle, when I have a diagonal going through my cylinder, this triangle is a right triangle. Okay, and again, I have two sides. I'm trying to find a third. So in that case, I would use Pythagorean theorem. So I'm going to do 15 squared plus diameter squared equals my hypotenuse squared. And then I'm going to solve that. And my diameter equals 8, which then means my radius equals 4. So now I have everything I need for my formula. I have pi, I'm going to take my radius squared times my height. My radius is 4. My height is 15 because it's the height of the solid. And then I multiply those things together. Traditionally, we're going to leave pi in the answer, like especially if we were in the classroom. So I'm going to leave pi in my answer here. Again, if we do something like a digital breakout or anything like that, where you can't write out the answer, you have to type it, you're going to have to multiply pi through because we don't have a pi button on our keyboard. But if we can write out our answer, I would like you to leave pi in it because it's something that you're going to see next year, and it doesn't necessarily just give you an answer. It's going to represent an angle, actually. So here I have my units are centimeters, so I'm going to do centimeters cubed, and that's my answer. All right, we have one more example because I want to show you how to do a combo problem with volume. Because we're doing volume, this is actually going to be I know in the past combo problems with surface areas have been kind of difficult and tedious. With volume, they're actually really easy because I'm talking about the insides of the shapes now. So for this prism, I'm just talking about the inside of it, so all the way inside. And so that means I can find the volume of this and it works. Okay, for this shape, I'm finding the volume of this. And I can just find volume. So I'm just taking the volume of this prism and the volume of this prism, and I can just add them together. There's no subtraction. I don't have to worry about, you know, the overlap that's happening here and here at all because that's the outsides of the shape. And because we're finding volume, we're focusing only on the insides. So there's no subtraction that needs to happen here. I just need to find the volume of my two shapes here, and then I add the volumes together and we're done. Okay, so this is a lot easier than what we've done in the past with surface area. All right, so my total volume is going to be the volume of the, let's say, shape A plus the volume of shape B. Okay, so the volume of shape A is a prism. So to find that, actually, hold on, I don't want to confuse you. Let's make that A. Okay, it is a prism, so I'm going to use the prism formula, which is the area of the base times the height. Okay, so I have to find the area of the base. Again, I always use the bottom. It really helps. Because this is a rectangular prism, the 5 here comes down and that becomes the base. And then my height that I need for the base right here is my 2. Okay, so when I find B, I'm taking 2 times 5, and that's 10. So I'm going to put 10 here. And then this, remember, is the height of the 3D shape, 3D solid. Okay, so this height and this height are completely different. So I need this height for the 3D solid. I don't have it, but what I do have is that the total height is 7, and the height of this shape is 4. Okay, so all of it's 7, this is 4, that means this has to be 3. So I multiply that by 3, and I get 30. Then I need to find the volume of the shape B. Again, it's still a rectangular prism, so I'm going to follow the same steps. I'm going to find the area of the base. This is my base, because I always use the bottom. So 7 and 3. When I multiply those together, I get 21. And then my height, again, we're talking about the 3D solid. So the 3D solid's height is 4. So I'm going to multiply that by 4. And I get 84. And now I'm not done because I have to actually add these 2 answers together to get the total volume of this combo problem. So I take 30 plus 84, and I get 114. And it's inches cubed. See, it doesn't like me. And that's how you do a combo problem. There's no subtraction. You just got to add the 2 volumes together. When they're surface area, they're subtraction. So make sure you know the difference.